Hello, welcome to this video, and in this video we'll be looking at an application of differentiation. First application we're going to look at is finding the equations of tangents and normals. Now we know that differentiation enables us to get the gradient function of a function. In other words, it helps us to get an expression for the gradient of the function at any point on its curve. Now we know that the gradient of the function at a point is equal to the gradient of the tangent to the curve at that point. Hence, if we, in essence, get the gradient of the tangent and can, from that, calculate the gradient of the normal to the curve at that point and the equations of the tangents and the normals given the points. Let's look at some examples. So for us to find the equation of the tangent to the curve y is equal to x cubed at the point 2, 8, the first thing we would do is to differentiate this function. So we'll get dy dx as 3x squared. Remember, power becomes a multiplier and reduces by 1. So dy dx is 3x squared. Now at the point 2, 8, the value of dy dx at the point 2, 8 will be 3 times 2 squared, which is 12. So what does this mean? This means that the gradient of the tangent to the curve at the point 2, 8 is in fact 12. Because dy dx gives us the gradient of the tangent to the curve at any point. Now at the point 2, 8, we simply substitute for x with 2. And so that tells us that 12 is the gradient of the tangent to the curve at the point 2, 8. And so we can get the equation of that tangent because we know that the point 2, 8 lies on the tangent. So we could use y minus 8 out of x minus 2 is equal to 12 to get the equation of the tangent. And this gives us y is equal to 12x minus 16. Or you could write it as 12x minus y minus 16 is equal to 0. That's how we get the equation of the tangent to the curve. Okay, let's look at this question. We've been asked to get the equation of the normal at the point where the curve cuts the x-axis. Okay, so we have that y is equal to x squared times x minus 3. Now this is a product, so we could either choose to expand it or we could differentiate using the product rule. Let's use the product rule. Product rule will tell us we have u times dv dx. dv dx is 1 plus v times ddx. ddx is 2x. And so this gives us x squared plus 2x squared minus 6x, which is just 3x squared minus 6x. And so this is the derivative of the function we've been given. Now, at the point where the curve cuts the x-axis, you know that at the x-axis y is 0. So we'd have to find the x coordinates of the point where y is 0. So how do we do that? We let y to be 0 in this equation. So when y is 0, we have that x squared times x minus 3 is equal to 0. So we could either have x squared being 0, which implies that x is equal to 0, or x minus 3 is equal to 0, which implies that x is equal to 3. So we have 2 points that we might want to consider, the point 0, 0 and the point 3, 0. But why don't we want to consider 0, 0? Remember, we want to find the equation of the normal. We know that, okay, so the gradient of the curve at the point 0, 0, the gradient of the tangent to the curve at the point 0, 0 is going to be 3 times 0 squared minus 6 times 0, which is 0. And that would mean the gradient of the normal, you know that the gradient of the normal is the negative reciprocal, the gradient of the tangents. The gradient of the normal at 0, 0 would be negative 1 out of 0. Now this is undefined. Of course, you know that in practice, that means it's going to give you a straight line, a straight vertical line. But this is undefined. So we're going to go with the other point, which is 3, 0. Yeah. So we go with dy dx calculated at 3, 0 will be 3 times 3 squared minus 6 times 3, which is 27 minus 18, which is 9. And so the gradient of the tangent at 3, 0 is 9. Therefore, the gradient of the normal to the curve at 3, 0 is negative 1 out of 9. So what does that tell us? That tells us that y minus 0 out of x minus 3, since we're looking at the point 3, 0, is equal to negative 1 out of 9. We want to get the equation of that normal. So this gives us 9y as 3 minus x, and therefore x plus 9y minus 3 is equal to 0, is the required equation. And that's how we find the equation of the normal.